Welcome back. In this video, we're going to work on section 5.4, which is about solving story problems using systems of equations. So it's important to note as we get into this that we actually know how to answer or solve all these problems using one variable, as we saw early on. But all these can be approached using a systems of equations kind of point of view too. And so that's what this is about. So let's start with some examples. The big difference here is between the way we did this now and the way we did it before is that we're going to be using two variables and we'll end up with two equations. So in this first one here, it says the sum of two numbers is negative 23. One number is 7 less than another. Find the numbers. So the problem itself has three sentences in it. The first one, the sum of two numbers is negative 23. That one is going to translate into one equation. The second one number is 7 less than another will be our second equation. And then the part where it says to find the numbers is just the piece that's giving us the directions, telling us to go ahead and do it. Okay, so I'm going to make the one number be the x, and whatever the another number is, the y. Okay, so one number will be x, and another number will be y. So here it says the sum of two numbers. Sum means addition, so we're adding those two numbers together, and it's going to be negative 23. So that's what our first equation is like. Now, one number, that's the x, is 7 less than another. You have to be careful with less than because remember, subtraction is not commutative. It matters what order you subtract in, right? Okay, so there's our system of equations, and you can solve these using substitution or elimination, whatever your favorite method is. Graphing, if you really like to suffer. If you really like, you can do this via graphing as well. So this one is kind of good for substitution because the second equation is already solved for x, so we'll just substitute that into the first equation. So x, also known as y minus 7, plus y equals negative 23. And so this will be 2y minus 7 is negative 23. Adding 7 to both sides, 2y will be negative 16, so that y is negative 8. Once you know the value for one variable, you substitute to get the value for the other. Here, we're told that x is y minus 7. So negative 8 minus 7, that's negative 15. So one number is x, that's the negative 15. So negative 15 and negative 8 are our two numbers. Okay, and that's that. So this should have a lot that feels kind of familiar about it. It is a system of two equations and two unknowns, but again, remember that you could have done this using just one variable if you had chosen. Okay, let's try another example. The story here, it says a couple has a total household income of $84,000. The husband earns $18,000 less than twice what the wife earns. How much does the wife earn? So this one, we're only asked to find one of the values, but we could do this using a system of equations. So let's try that. I'm going to use H for the husband's income and the W for the wife. You can use X and Y if you want, but it's easier for me if I use H for husband and W for wife. Okay, so the couple has a total household income of 84,000. So the wife plus the husband should be 84,000 altogether. That's that first sentence. Next, the husband earns, so husband, what he makes is 18,000 less than twice what the wife earns. So twice the wife minus 18,000, and that's what the husband earns. Again, you have to be careful with less than, as we saw in the previous example. Okay, so once again, this one will be good for doing substitution, so let's do that. So I'm going to take and replace the h in the first equation by 2w minus 18,000. So we'll have w plus 2w minus 18,000 will equal 84,000. So we have 3w minus 18,000 is 84,000. And then next we'll add 18,000 to both sides. So we'll have w is 80,000 plus 18,000. That's a lot of zeros. Okay, so 84 plus 10 is 94. 94 plus 8 is 104, but take away 2, looks like 102,000. And then we'll divide through by 3. So 102 divided by 3 is 34. So W will be 34,000. Okay, so the question is asking us what the wife earns. So she earns 34,000. Okay, and that's the answer to our question. Be careful, by the way, to make sure that you're answering the question that's being asked. Here, we weren't asked what the husband earned. We could figure that out if we wanted, but that wasn't the question. So we just answered the question that we're being asked. Okay. Okay, next example. This one is an age problem. Here it says Tom is 12 years older than Anne. The sum of their ages is 40, and we want to find their ages. So take a minute, pause the video, try to set this up yourself. I'm going to be using T for Tom and A for Anne for the variables. So pause the video, see how you do when you restart it. Okay. All right. So T is Tom's age, A is Anne's age. So we'll say that the sum of their ages is going to be 40. And we know that Tom is 12 years older than Anne. So there's our system of equations. And once again, this one is good for substitution, but we've done a lot of substitution. So I feel like doing elimination this time, just for fun. And so I'm going to take the second equation and I'll subtract the A from both sides. So we'll have T minus A is 12. Okay, and so then when you add these two together, you have 2T is equal to 52. So that T is 26. Okay, it looks like Tom is 26. And then he's 12 years older than Anne. So she's 12 years younger. So that would make her 14. Okay, so differ by 12 years. And then also their ages add to 40. So that checks out. Here, if you had chosen to do that using substitution, that totally would have fit with the previous examples we had done. And in fact, it was good for substitution. I just felt like doing an elimination problem. Okay, this problem is nice and long. Be careful when you see problems like this on a test because it's very easy to look at that and say, wow, that's too long. Let me just skip it. But it's just kind of wordy. As you'll see, this is not too bad once we start breaking it down. All right, so here it says Erin spent 30 minutes on the rowing machine and 20 minutes lifting weights at the gym and burned 430 calories. So this is kind of like one day. She had this workout where she spent time on the rowing machine and time lifting weights and burned a certain amount of calories. Often remember that story problems, the thing that you're trying to find is at the end. So let's skip all this and look at the end and say, okay, well, how many calories did she burn for each minute of weightlifting? And how many calories did she burn on the rowing machine? So we want to know how many calories she burns using each of these two activities. Okay, so her next visit, she spent 50 minutes on the rowing machine, 10 minutes lifting weights, and burned 600 calories. And then finally, the last sentence is the question. So here there's really only 3 sentences, I think. So variables. Let's go with R for rowing machine. This will be the number of calories burned per minute on the rowing machine. And W will be for the weights. How many calories she burns. And I should be more explicit about that, just so we're clear. So this is calories per minute burned rowing. And then this is calories per minute burned on weights. Okay, so let's see if we can take that first fact or first day that Erin went to the gym and turn that into an equation. So she spent 30 minutes on the rowing machine. So the calories she'll burn is 30 minutes times R calories per minute. And then 20 minutes doing weights. So this is 20 minutes doing weights. And there she ended up burning 430 calories. The next minute, next visit, it was 50 minutes rowing and 10 minutes lifting weights, and she burned 600 calories. Okay, so it's important to note here what each quantity on each side of the equation is. The quantities are calories on each side of the equation. In an expression like 30R, it's 30 minutes, and then R is in calories per minute. So when you multiply R times the 30, the minutes cancel, leaving you an answer in calories, which is what we wanted. Okay. So the equations here should make sense. If they don't make sense, let me know. If you have any questions on that, we could talk about it more. Here, the number is a little bigger. Often you'll see that in story problems that because they're trying to make it realistic seeming, they make the numbers a little larger. So it's worthwhile to take a little time to kind of pre-process the equations before you jump in and start solving them. So one thing I can see is that the first equation, all the numbers end in 0. So I'm going to go through and divide by 10, and that will lower the sizes of the coefficients. So we'll have 3R plus 2W, and that's equal to 43. Okay, number's a little more manageable there. In fact, we can do that with the second one also. Let me divide through. At first, I was going to divide through by 10, but if it's all the same to you, I'm going to divide by -5. Okay, I want to divide by -5 just so that the coefficient of W here will be -2. 10 divided by -5 will give us -2. And I want something to match up with our 2W that's above. Okay, so 50 divided by -5 is going to be -10. 10 divided by -5 is -2. And then 600 divided by -5 is going to be -120. Okay, so now we should be able to do this using elimination. We should be able to get the W's to add up to 0. So this will give us -7R. And then we have 120 minus 43. And that's 77 negative. Okay, so R is 11. Okay, and then once we have the value for R, we'll need to go back and get a value for W. I would choose an equation that's got small numbers in it, but you can use any equation that has both variables. We'll use that upper one. 3R plus 2W is 43. So 3 times 11 plus 2W makes 43. 33 plus 2W is 43. 2W is 43 minus 33. Okay, to celebrate our conclusion of the question, Zoom crashed once again. Sorry about that. So it was 5 calories per minute on weights, and then 11 calories per minute rowing. Once again, make sure that if you're either taking a paper test with this on it or doing this on like some kind of computer homework, if there's an answer box for each of these things, make sure that you put the right number in the right box, right? It's a bummer to go through all this work and then put the 5 where you should have put the 11, right? So be careful about that. All right, so in hindsight, even though the problem looked kind of long, hopefully you didn't find it too much work in the end. The hard part usually is coming up with the equations. And then in this case, it only took like 2 steps to solve it. All right, that takes us to the end of this first part of this section. In the next piece of this, or in the next video, we'll continue the same section with more examples. In the meantime, let me know if you have any questions and have a great day.